Um, if you look at these examples, like this example too, actually what it says is find all the solutions of that equation in the interval 0 to 2 pi. And I just wrote, solve 0 to 2 pi, meaning we're just going to find in that interval. It doesn't always say that, right? Sometimes it just says find all the solutions, and the answer ends up looking a little bit different. Although, the homework, all of them say 0 to 2 pi. They don't have any section that does the find all the solutions, but the examples will. They'll have some of those. So generally, when you solve the trig equations, the first step, you got to isolate the trig function, which has the variable inside. Just like all kinds of logarithms and radicals or whatever, usually there's an isolate at the beginning. So we do need to isolate. I want to be in blue. Isolate the trig function. And, if there's more than one trig function, then somehow you got to get them together, right? And that could involve algebra. It could involve using our identities. In this case, you got sine x on both sides, so you need to get sine x's all together. So use a little algebra. Either subtract sine x to this side or add sine x to this side and subtract the square root of 2, right? Let me do minus sine x minus sine x. And this will be the square root of 2 equals negative 2 sine x. Right? Still not isolated. Divide by negative 2. So sine x equals negative square root of 2 over 2. And that's familiar, isn't it? Right? That's one of our unit circle coordinates. So in between 0 and 2 pi, go to the unit circle. Where does sine equal negative root 2 over 2? 5 pi over 4? 7 pi over 4. So your two answers are x equals 5 pi over 4, 7 pi over 4 from the unit circle. And because you can see that it's a unit circle coordinate, then you should just think immediately to do that. Could you have done sine inverse of negative square root of 2 over 2? Yeah, unless the problem said exact, right? And then you wouldn't want to do that. You need to have it with the pi involved.